Okay, grade 9, this is Thursday, June 13th. We're doing a 9 for review for your exam, which will be on Tuesday morning, first and second period. So these 9 questions are taken from 9 of the 11 chapters in the book. Questions 5 kind of combines 2 chapters on multiplication of polynomials with the addition and subtraction of polynomials, so we kind of combine that one together. But if you'd like and you don't have this, the paper copy, you can press pause, try these questions, and then press unpause to see what the answers are. The first question gives you a star and says, how many lines of symmetry are there, and what is the angle of rotation? Well, if we think about symmetry, line symmetry, if I was to draw a line there, then each point on this circle, there and there, this point is equidistant and perpendicular from its corresponding point. This point here would be the same distance from the line of reflection as that point and perpendicular. This point, and etc., etc. All of those points would be equidistant and perpendicular to the line of reflection, and therefore it is symmetrical from that line of reflection. So too would this line. Oh, that's not very good. So too would this line. So too with this line. So too with this line, and finally so too with that line. Roughly, if I was able to draw a straight line. So the answer is there are 5 lines of symmetry. 5. Oh, hang on. 5 lines of symmetry. Okay. Now the second part of the question says, what is the angle of rotation? What I'm going to do here is just going to erase all this stuff here for a second. And I'm going to bring in this other star. Oh, hang on. Right here. I'm going to put it on top of it. Now, the angle of rotation Sorry for technical difficulties there. The angle of rotation is calculated by taking 360 degrees, which is one full rotation, divided by the order of rotation. Now the order of rotation is a fancy way of saying, if I take this circle and rotate it 360 degrees, how many times does it appear as itself? So there's the first one. Now we have to imagine that this star was perfect. It's not, but we'll pretend it is. It appears as itself once, twice, 3 times, 4 times, and finally when I go all the way around, 5 times. So we say the order of rotation of this star, if it were perfect, is 5. So 360 divided by 5 is 100, well, I'll do it here. Sorry, it's not 72. So 360 divided by 5 equals 72. So therefore, what that means is, as I rotate this star 72 degrees, that is a rotation of 72 degrees. And what ends up happening when I rotate it 72 degrees is I have a duplicate of the image itself. As I continue another 72 degrees, I have it again, another 72 degrees, another again, another 72 degrees, I have it again, and another 72 degrees, and I have itself matched up again. So the answer is the angle of rotation is 72 degrees. Next question. What is the square root of 25 over 144? So there are 2 ways you could really solve this question. The first way is to think about what fraction multiplied by itself gave you 25 over 144. And since 25 and 144 are both perfect squares, you would have 5 and 5 in the numerator, 12 and 12 in the denominator. And therefore, as a fraction, your answer is 5/12. Conversely, you could have taken a calculator, and you could have said, well, what is 25 divided by 144? And it would tell you it's this. Then take the square root of that. Sorry, the square root is right here. And it will tell you 0.4166. So the answer as a decimal is this. The only problem is now you have to retranslate that back into a fraction, which is hard. So the best way to do it on your test, since it is asking for the square root of a fraction, ask yourself what fraction multiplied by itself is that. Think about what the numerator has to be, and think about what the denominator has to be. Next question is a BEDMAS with three exponential forms. Now remember, the key here is this point, and I can't stress this enough. These 2 things are not the same thing. Negative 2 squared means negative 2 multiplied by itself twice for positive 4, and this means the opposite of 2 squared, which is the opposite of negative 4, so or the opposite of 4, which is negative 4. So therefore, this one here has a value, a standard form value of negative 4, plus this one here would have a standard form value of a positive 9, because we have negative 3 times negative 3, which is positive 9. And 1 to the exponent of 5 is 1 multiplied by itself 5 times. 1 times 1 is 1, etc., etc. It's still going to be 1 in standard form. Now we have simplified our exponents. We have two operations left. The first one I'm going to do is multiplication. Don't forget bedmass. I'm going to have, sorry, that's negative 4 plus positive 9. 9 positives and 4 negatives make positive 5, which is your answer. Next question, what are the lengths of x and y? We need to use proportional reasoning here. So because these two triangles, I guess we should have said they are similar, and their sides will be proportionate, which means 3 to 3.6, or this side to its corresponding side of 3.6 will be proportional to this side, 5, and its corresponding side of y. When I cross multiply, I'm going to get 3y equals 18. Divide both sides by 3, and y will equal 6. So y is 6. Now the second part says what is x as well, so I'm going to solve that. So again, I'm going to use that 3 to 3.6. 3 to 3.6 is proportional to x to 4.8. Use that cross multiplication to solve it. 3.6x equals 14.4. Divide both sides by the coefficient of 3.6. And 14.4, divided by 3.6 is 4. So therefore, x is 4. Now, alternatively, you could have said, you know what, I'm going to do this a whole different way. Alternatively, you could have said, oh, hello. You could have said, this was my actual, this was my diagram, okay? So then I could have said, diagram divided by actual equals scale factor. So 3.6 divided by 3, or 3.6, the d divided by a. 3.6 divided by 3 is 1.2. So the scale factor is 1.2, which means if I multiply my actuals by 1.2, I will get y. So 5 times 1.2 is 6. And x times 1.2, x times 1.2 equals 4.8. I actually have an algebra question. X multiplied by 1.2 equals 4.8. Divide both sides by 1.2, and x will equal 4. Easy peasy. Next question, true or false? 2x multiplied by x minus 3 is the same value as 3x squared plus 1 minus 6x plus x squared minus 1. And I think we made the correction. I should change this because we said we want to make this a minus. I had made a mistake here, minus x squared. So let's see. The first thing I want to do is expand this using distributive property. So I'm going to multiply both parts by this. So 2x times x is 2x squared, and 2x times negative 3 is minus 6x. When I look at the bottom part, I have to gather like terms. It's addition. So 3x squared and a negative x squared make a positive 2x squared. A negative 6x, there are no other x's to connect with, so it just becomes negative 6x. And those become a zero pair. So when I simplify it, I do see that indeed both of those were the same thing, so the answer is true. Next question comes from your linear relations chapter. So what we did in this chapter is if you have a pattern like this, you put n and v. The n stands for the number in the sequence, in this case the first number, the second number, the third number. The first number's value is negative 10, the second number's value is negative 5.5, and the third number's value is negative 9. What is the 100th number would be what is n when it's 100. So the first thing I have to do is find my equation. If I look down here, when I'm going from negative 10 to negative 9.5, I'm actually going up by 0.5. Some people think I'm going down, but I'm actually going up by 0.5. And here, I'm going up by 1. To find the coefficient in your equation, you take the difference in y divided by the difference in x, and that's going to be your coefficient. So 0.5. And now another way you could write that, of course, is n over 2. They're both the same, half of n. Once you know your coefficient, substitute your first ordered pair. This is 0.5. Does not equal negative 10, but if I subtracted 10.5 from it, I would end up with negative 10. So therefore my constant has to be negative 10.5. And now once I have that equation, I substitute my 100 for n, which is going to be 50, minus 10.5 will equal my v. So therefore 39.5 is the value of the hundredth number. Next question is an algebra question, solve for x. So we have two sides that have variables on it, and both require us to expand using distributive property. So I'm going to expand this to become 2x minus 6. I'm going to expand this to become 4x plus 8. Now remember, when you have variables on both sides of the equation, the first thing you have to do is get rid of from the side that has the least amount. So I'm simply going to subtract 2x from both sides, because algebraically, whatever you do to one side, if you do to the other, you maintain equality. That's going to be negative 6 equals 2x plus 8. Get rid of your plus 8 now, because we have working towards isolating for x. 2x will equal negative 14. Divide both sides with a coefficient, and x will equal negative 7. In your next question, you have an inequality. And what you have to do here is solve the inequality. Now, there's some secrets here that you have to remember. So I'm going to take this equation, and I'm going to move it over here. So the first thing, we're going to treat it just like we would an equality. We're going to expand using distributive property. We're going to get rid of your constant, by subtracting 12 from both sides. But now you have to remember this very important thing, and this is the only thing that you really have to remember. It's one of two things that are important to remember in inequalities. When you isolate by dividing both sides by a negative value or multiplying by a negative value, you have to take this sign and you have to flip it. Otherwise, your inequality will not be true. So 2 divided by 4 is 0.5. A negative divided by negative is a positive. So therefore, you end up with this all values less than or equal to negative 0.5. So 0.5 is going to be my middle, 1 is going to be here, and 0 is going to be here. All values, you always start from your variable, less than or equal to, meaning if it's not eating it, it's the word less than. So all values less than or equal to 0.5. Now because it can be equal to, because of this it can be equal to, remember you need a closed boundary point. And all values less than 0.5 or equal to 0.5, it's a closed boundary point, and that particular arrow. And the last question is your circle geometry. It says that AB is 10 meters. So this is a chord, and it is 10 meters long. And because this radius cuts it perpendicularly, what you learned is if you cut a chord perpendicularly with a radius, it cuts it into 2 equal halves. So since AB was 10, then this part of the chord is going to be half of 10, which is 5. AC is the distance from here to here, otherwise known as a radius. It defines it as being 6. So if I redraw this triangle, I have a 6, a 5, and an x. This x will actually be the distance of CE. So I'm going to add on my squares. This is 25, this is 36, this will be 11. X will be the square root of 11. Take 11, press the square root sign, I get 3.3. So this distance here is 3.3. Now remember, this distance here is a radius, and the whole distance from C to D is a radius as well. So if part of that CD is 3.3, then the rest of it must be the remainder of the 6, which means ED is 2.7. Because this plus this is that whole line, and that whole line is the radius, which is the same as AC.